Hey guys, Mr. Frazer here, and this is day 5, talking about fractions. Yes, fractions again. We've already done parts of a whole. We've already done parts of a group. We've already done fractions on a linear line. And yesterday you did equivalent fractions and made some fraction cards. Today we're going to use the cards you made from yesterday in order to play games today. If you don't have the cards, I linked in the description below. I linked the video from yesterday. So go ahead and take a look, create those fraction cards from yesterday. Now, today we're going to talk about ordering and comparing fractions. But before we do that, maybe a little explanation is in order. So let's talk about comparing fractions and ordering fractions. These are two related concepts that we need to be able to do in order to talk about our math understanding. So when we compare fractions, we want to see which fraction represents a bigger piece of the whole. Now, this works when we're comparing fractions of either the same whole or of the same group. It does also work, but it gets a little trickier if we're doing like 1/3 of 12 cupcakes versus 5/16 of 24 cupcakes. Those are two different things, but today we're going to talk about all with parts of a whole. Maybe later we'll move into parts of a group, but today we're going to talk about parts of the same whole. So when we're comparing fractions today, we're comparing parts of the same whole. We're going to use 3 signs to compare fractions. We're going to use the less than sign, the greater than sign, and the equal to sign. Now, a lot of teachers have always taught like, oh, it's an alligator, and this is an alligator mouth, and it's going to eat the bigger number because it's hungry and it really wants to eat the most. So if we're comparing some, we say that this is maybe 6 and this is 8. The alligator is going to eat 8, of course. And then the next sign would be greater than. And if the greater than is facing this way, 8 is greater than, let's say, 3 here. So you can think about those as if it's a mouth trying to eat. And which side is it pointing to? It always helped me out when I was a kid. Maybe it will help you out too. Ordering, we need to compare many fractions and place them in order. Okay? So normally we order from smallest to largest or from least to greatest. Those are two different ways of saying it. In fact, let me write it down here. Least to greatest. And that's simply just putting the smallest number first and the largest number last, or the smallest fraction first and the largest fraction last. So we're going to do a warm-up activity where we're going to compare a couple fractions, and then I'm going to show you a couple games. So let's jump on over to the warm-up activity. All right, guys. Now, what I have here is a warm-up activity that is going to get our brains thinking about comparing fractions. So it's very, very simple. All we need to do is we need to think, are we going to use the less than sign, the greater than sign, or the equal to sign to compare these sets of fractions? So I'm going to give you a second. If you need a little bit longer, make sure to pause the video. But I'm going to give you a second to decide, are we going to use a less than, greater than, or equal to sign to compare these two fractions, and these two fractions? So go ahead and have a think. Great. Hopefully you were able to figure that out. So let's compare the first two. Now, the first two are the easiest two to compare because they have the same denominator. And when we have the same denominator, we're comparing the same size pieces, which makes it easy. Which one has more pieces? So here there's a visual representation of a circle cut into 8 pieces, here and here. This circle has 5 pieces colored in, and this circle only has 3 pieces colored in. So we can visually see that this piece is much larger than this piece. So we're going to use the greater than sign. Now, when we read that, we would read that as 5/8 is greater than 3/8. Now let's look at this one. This one I use words to write it out because guess what? You need to be able to read fraction written as words as well. So I have 3/4 over 5/8. Now these ones are not the same denominator, but they're related denominators, which makes it a lot easier. If I write these in numbers, I would have 3/4 over 5/8. Now, it's pretty tricky to compare fractions with different denominators. So what we would want to do is we would want to change a fraction into another equivalent fraction so that the denominators match. 4 and 8 are really related to each other. In fact, I know that if you double 4, you get to 8. So all I would need to do would be to double the denominator and the numerator in order to make an equivalent fraction with like denominators. So if I double them, I would get 6/8. Now my denominators match, which makes it really easy for me to compare. If my pieces are the same size, which one has more pieces? 6/8. So again, we're going to use the greater than sign. So if we look here, we have 3/4 is greater than 5/8. Now here's our last one. And this one seems tricky because we're not using an even number like 2, 4, 6, or 8. We're using an odd number, 3 and 9, and 15 and 45. This is the first time we've gotten up to a fraction this big. Well, at least it seems very big, but it might not be. So now I'm going to look at these two fractions here. I could draw a picture to represent each fraction and then compare them that way, but that might take me a long time. And I know that if I tried to make a shape and divide it into 45 equal pieces, it's going to be really difficult for me to do that. So I'm going to have to use some multiplication and division in order to figure it out. Now, instead of making one fraction bigger, I'm going to try to reduce a fraction, which we talked about on day 3, reducing fractions. Now, I could reduce this fraction here because I know that 3 is divisible, or 9 is divisible by 3, and 9 is a multiple of 3. So I could divide both of these by 3. 3 divided by 3 and 9 divided by 3 equals 1/3. Okay? So now, instead of using 3/9, I can simply use 1/3. I reduce the fraction down to 1/3. Now, with 15/45, that's a little bit tricky. But luckily, I'm going to compare it to something I know, which is a clock. And when we tell time on a clock, we like to use 15-minute increments. We say 2:15 or 9:15 or 8:30. So we use 15-minute increments in order to break up a clock. So I know that 15 and 45 are multiples of the same number. So, thinking about what I know about clocks, I'm going to use something called the greatest common factor. And a factor is a number that is used to multiply in order to get another number. So if I think about the factors of 15, I know that I can multiply 1 times 15, and I can multiply 3 times 5. And both of these factors will give me 15. 1 times 15 and 3 times 5. Now if I think about 45, I know I can multiply 1 times 45. I know I can multiply 3 times 15. And I know I can multiply 5 times 9. So now if I compare these two sets of factors, and I find the biggest one that they have in common, this is called my greatest common factor, which is 15. So now if I divide both the numerator and the denominator by the greatest common factor, which is 15, I'll get a reduced fraction. 15 divided by 15, 45 divided by 15, that will give me 1/3. So now after all of that work, and all of that trickiness, I've decided that 15/45 is just another way to write 1/3. So now I need to compare 1/3 to 1/3. Wait, isn't that the same fraction? You're right. So 3/9 and 15/45 are what are called equivalent fractions. Okay, now that we've worked on this, we're going to jump over to the table and I'm going to show you 3 games that you can play with the cards we made yesterday. So, grab your gear, meet me on over. Hi guys, welcome back to the table. Today we are going to be learning 3 games that we can play with the fraction cards we made yesterday. If you didn't complete the fraction cards from yesterday, it's okay. Go ahead and take some time today in order to finish them. They're very important and we're going to use them a lot as we get through the unit. We're actually going to use them with decimals too. So what you need today are your fraction cards from yesterday, maybe something to write with and something to keep score on. Okay, and then possibly a timer. I'm just going to use my cell phone for a timer. So these are some things that you could use today, but really all you absolutely need are your cards. Okay, and the first game we're going to play is a memory game, and I'm pretty sure most of you are familiar with this game. In Mr. Frazer's class, we play this game with our vocabulary words as well. So all you're going to do is you're going to shuffle up your cards as best as you can. Okay. You're going to mix them up, switch them around, maybe make a little pile, shuffle them up, okay? And then what you're going to do is you're going to lay out a 4x5 grid. But at this point, you want to keep the cards face down so you can't see them. So I'm going to go ahead and just to keep things simple, I'm only going to do a 3x4 grid just because I don't think I have quite enough room on my space here. So hopefully all of these are in frame. Yeah, they should all be in frame here. So now I have these face down, and what I'm going to do is I'm either going to play by myself or I'm going to play with a partner. I'm going to take my extra cards and I'm going to keep them in a pile and I'm going to keep them face down so I can't see them. Okay, and I'm just going to set them over here. So now what I'm going to do is I'm just going to flip over a card, okay, 16/24, and I'm going to flip over another card, 1/4, okay. Now I need to see if these two are equivalent fractions. That's my job. Now I know that 24 is a multiple of 4, so I'd have to multiply by 6 to get 24. So that would be 6/24, and this is 16/24, so they're not multiples. So now it would be the other person's turn. 12/16. Well, I know that's a multiple of 3/4, so I need to find 3/4. 12/32. No, not so much. I know because they have the same numerator but different denominator, so I know that they're not equivalent. 12/32. Let's see here. 9/12. That's the same as 3/4. And this one here, 12/16. That's the same as 3/4. If I divide each one of these by 4, 12 divided by 4 is 4. 16 divided by 4, or sorry, 12 divided by 4 is 3. 16 divided by 4 is 4, so that'd be 3/4. If I divide the numerator and the denominator by 3 on this card, 9 divided by 3 would be 3. 12 divided by 3 would be 4. So 3/4, 3/4. I can also compare the pictures. Okay? So this is a match. And what I would do is I would take these and I'd set them on my pile, and I would put 2 new cards without looking at them into place. Then we keep playing, keep playing, keep playing until we're out of cards. Then we count the cards at the end, and whoever has the most is the winner. Very simple game. So that's equivalent fraction memory. So give that one a go. Game number 2. Game number 2 starts the same way as the first game, where we shuffle our cards up, okay? And we mix them up so they're not in order. We don't want them to be in order. This game is called Comparing Fractions War, or we can just call it War for short. So what we need to do is we need to make 2 equal piles of our cards, okay? Now, if you have a complete set, it would be 20 and 20. Okay? So 2 equal sets of cards. One person would have one set, and the other person would have the other set, like this. Okay? Then on 3, on the count of 3, you would flip over the cards. 1, 2, 3. Okay? 4 8s and 9 12s. Now, you would compare the fractions to see which ones are bigger. And we're going to you could use the fractions that we did yesterday as your benchmarks in order to figure out, well, maybe I should reduce the fraction in order to decide which one is bigger. Now here I can just look at the pictures and I can see, well, this one takes up more of the whole than this one. In fact, this one is 3/4 and this one is 1/2. So the bigger fraction gets both the cards. And what you do is you take them and you put them on the bottom of your pile. Don't put them on the top, put them on the bottom. Now, what happens if we get, let me see, until we get one that's the same. If we get 2 that are the same, like this. If we get 2 cards that are equivalent, okay? So 1/8 is equivalent to 2/16. If that happens, there's no winner right away. What you would need to do is flip a second card on top and then compare those. Which is bigger, 1/2 or 3/4? That would mean that this person gets all of the cards. They go on the bottom of their pile. And you keep playing and playing and playing until there are no cards left. That would be fraction comparing war. Great. Give it a go and see how you like it. The last game is the trickiest game. You're going to take your cards again and you're going to shuffle them up. Now, if you have somebody you can play against, that would be great. But if you don't, this is probably the best game to play by yourself. What you're going to do is, this is called ordering race. So what we're going to do is we're going to lay out 5 cards face down. 2, 3, 4, 5. Now, if I was playing against somebody else, they would lay out 5 cards. If not, I can use a timer in order to time how long it takes me to order the cards. Now, we're going to order these cards from smallest to largest. So on the count of 3, I'm going to hit my timer, and I'm going to flip these cards over. 1, 2, 3. And I'm going to flip them over like so. And I want to put them in order from the smallest fraction to the largest fraction. In fact, why don't I turn it like this so you can see. And I want to put them in order from the smallest fraction to the largest fraction. Now, if I look, I have 1, 2, 3, 4, 5 different denominators. So this is going to be tricky. I can't just put this one at the end or at the beginning, because I need to look at the numerator and the denominator. But if I look here, 4/32 is not very much. So I'm going to move that over here all the way to the beginning, because compared to what these three are filled in, these three circles, it's much, much smaller. Now I have 9/12, I have 12/16, and I have 3/4. Now I did my work earlier. Here you can see I wrote on here. 3/4 is the same, so I'm going to put those on top. 9/12, if I divide 9 by 3 and 12 by 3, it's going to be 3/4. So these are all three the same. So I would stack them like this. Now I need to decide, does this one go here or here, here or here, here or here? Well, 16/24. If I take 3/4 and I want to change it into 24, I would multiply by 6. So 3/4 times 6 would, or times 6/6 really, would be 3 times 6 would be 18. 4 times 6 would be 24. So it'd have 18/24. So that's smaller than 16/24. That one would stay here. So this is my completed ordering race, and I would stop my timer. Now, if I was playing against somebody, when I got done, I would put both hands down on the table and say, done. When I do that, the opposite person gets to check my answers. If my fractions are in order, I get the point. Yay! If my fractions are not in order, the other person gets to mix them up, and they have to start again. So that would be ordering fraction race. You can either play it with a timer by yourself or with a partner. Those are 3 games that you can play using these fraction cards that we created. I hope you had fun, and I'll see you next week. Awesome. Hey guys, Mr. Frazer here. I forgot to mention that I need you to take a video of you playing one of these games and upload it onto Seesaw. That way, the teachers and I can check to make sure that you make equivalent fractions and your fraction cards are great, and how you compare each of the fractions and order the fractions. So don't forget to record a short video, no more than 1 minute, and post it on Seesaw so we can see how you're doing with ordering and comparing fractions. Great. Talk to you soon.